is biopotential. Okay. So you can see that how this potential is developed. So this electrical potential exists. This you can just read it. Electrical potential exists across the membrane of virtually all the cells of the body. We are saying that the basic functional unit of our body is the cell, and the potential exists in all cells. Okay, so that cells could be muscle cells which is present in our muscles, or in the nerve cells which are nothing but the neuronal cells. So they are capable of generating some electrochemical impulses because of change in the electrolytes or ion movement. We can say that there is a electrochemical impulses are produced at their membranes, and these impulses are used to transmit the signals along the nerve or the muscle membrane. Okay. Mostly we are going to have the value of that potentials for the muscle cells and the nerve cells. Okay, so all the cells present in our body, those are capable of generating electrochemical impulses, and that impulses will be used to transmit the signals. Okay, so what are the cells and what are that structure, that it is important. So the potential generally are nomenclated as a membrane potential and the resting potential. So a membrane potential or a transmembrane potential difference that exists between the inner and outer surface of the plasma membrane, that is called as the membrane potential, and resting potential is a membrane potential of excitable cells at the rest. Okay, so resting potential, and when it is acting, that is called as the action potential. So we'll come to know about this terminology. So this is about a human cell. Okay, so in this diagram you can see the human cell is shown, a singular cell, and in that cell various terminology is present, that the nucleus is present, nucleolus, Golgi apparatus, mitochondria, lysosome. Okay, so we are not dealing about this, what are their functions and all these things. Our interest of study here is to study how these cells will produce the potential and how this potential is measured by an instrument. Okay, so you can only consider that this is a inner part. Okay, so you can see that this is the inner part of the membrane. This one is outer part of the membrane. Okay, so cell, inner cell, outer cell. Okay, we can say outer part of the cell, and this is nothing but the inner cell. And this particularly a membrane, this lining is called as the cell membrane. Okay, that is called as the cell membrane. So what happens, there is a fluid inside as well as outside. So that fluid is consisting of various electrolytes. So that fluid which is present in the inside is called as the intracellular fluid, and the fluid which is present outside is called as the extracellular fluid. Okay. So this is nothing but ions. It is consisting of various ions, maybe the potassium, chloride, sodium. These are the major ions which are present. Okay. Can you tell me whether the potassium chloride ions are positive or negative, or sodium ion is positive or negative? Can you tell me potassium ion, is it positive or negative? Anybody of you? Potassium carries which ions? Potassium
Positive.
positive. Is it? Any answer? Other answer?
Negative, sir.
Yeah? Sodium carries
Negative.
negative. Acha. And chloride? See, this is basic. You might have studied, okay, in the 10th or 12th. So I'll
Chlorine negative, sodium positive.
sodium positive आणि chloride
Negative,
negative आणि potassium
positive.
positive. Okay. Okay. Now let us see. It will you'll come to know. Just will be seeing it. I'll just share you the another one. Okay. When we will come to that point. Now the about this chloride and this thing. So I'll share the another PDF file so that we will study how the potential is developed. Now just you can see here. As I said, the cell is there like this. So inside the cell, the fluid is present, which is called as intracellular fluid. Outside the cell, it is present, that is called as the extracellular fluid. And this is nothing but the membrane, which is the membrane, which is separating inner part and the outer part of the cell. This is nothing but the cell. So what happens? The fluids are nothing but conductive solutions containing the charged atoms called as the ions. Okay. So what are these ions? These are ions: sodium, which is positive, potassium, which is positive, and chloride is negative. Okay, now you keep this in mind. Sodium ion carries the positive ions, potassium are the positive, and the chloride are the negative. Okay. So what happens? This membrane of the excitable cells readily permit entry of potassium and the chloride ions. Okay, initially what happens? Suppose we are starting from the rest. Okay, so in the rest, what will happen? The characteristics of this membrane, this this membrane is semi-permeable. Okay, semi-permeable means what? It is not. It is allowing some of the ions to go inside, and some of the ions it will not allow. Okay, so it will be possible. So which ions it will block? It will block the sodium ions. Sodium ions cannot go inside. Okay, but potassium and the chloride ions can move from inside to outside or outside to inside. That it is possible, but the sodium ions cannot be able to get in. Okay, so the membrane is excitable cells readily permits entry of potassium and chloride initially, but effectively blocks the entry of the sodium ions. Okay, so what will happen? So because of the concentration gradient, what will happen? The concentration will be different. Inside the concentration will be different, outside it will be different. Okay. As we can say that sodium ions are not allowed to get inside, then what will happen? There is a deficiency of sodium ions inside initially. Okay. Deficiency of sodium ions inside. Now sodium ions carrying positive charge, that means what? Deficiency of the positivity inside the cell initially. Then another thing is what? Even though the concentration of sodium is high outside and less inside, the sodium will try to rush in. But because of this membrane is not allowing the sodium ions to go in, there will be will not be able to get inside the sodium ions. Okay. And another time what will happen? The potassium are more inside and less outside, so that potassium ions will try to come outside. Okay, So the potassium ion, if you see, okay, so that potassium, because of the gradient difference, it will try to come outside. So potassium ion carrying the positive charge. Okay, potassium ions are carrying the positive charge. Again, what will happen? That these potential ions, potassium ions, will be again coming outside. Okay, so that means what? Again, it will be having the deficiency of positivity inside because of the potassium also ion also are going out. Okay, that means what? Initially, when in the rest condition, that we are calling as a resting condition, the sodium ions cannot be able to enter inside, potassium ions are going outside, so it will create a negativity inside, and that negativity is nothing but the negative potential if you measured the inside of the cell than the outside. Okay, and that potential is nothing but called as the resting potential. Okay, resting potential. Okay, so just wait, I'll show you if it is having the diagram. So this is the case. Okay, so you can just see this diagram. So here, this is a membrane. This is the extracellular fluid, ECF. It is intracellular fluid, ICF. Sodium ions are more outside. Potassium ions, that is concentration gradation, and because of this, what will happen? It will create a electronegativity. You can see the negative atom. Okay, you can see the electronegativity inside. And when you are measuring it with respect to inside and outside, that it is nothing but it will be called as the resting potential, and that resting potential generally have is minus 70 millivolt. Okay, so you can see here minus 70 millivolt is present, and that potential is called as the resting potential. Okay, that potential is called as the resting potential. Okay, so what are the things you can keep in mind? How the cell is producing the potential? So first one, during the rest position, there is an imbalance of the ions outside and inside. Second thing, the membrane which is present, which is called as the cell membrane, is semi-permeable in nature, which is allowing potassium and chloride ions to come in and out, but sodium ions it won't allow. So since sodium ions carrying the positive ions, these are more number in outside than inside. That's what negativity is there inside. Again, this negativity further increases because of potassium ions going outside. So again, it will become more negative. So when you measure with the potentiometer with respect to outside, you can see that it will produce a negative potential, and that negative potential is the resting potential. Okay. So here the resting potential is minus 70 millivolt is taken for the muscle cells. You can say, hello, any problem? Am I audible? Any problem is there?
No,
Hello.
sir.
Okay, if somebody has a problem, so you can ask me. Otherwise, I will continue. Okay. So for muscle cells, it is minus 70 millivolts, and if you go for the nerve cells, means which are the nothing but the neuronal cells, it will be minus 90 millivolt. It will be minus 90 millivolt. Okay, but the term is called as resting potential. Okay, resting potential. So this is the first stage, first cycle, resting potential. So resting potential is negative. It is having electronegativity more negative than outside, and that's what it is called as the resting potential, and having the value of minus 70 to minus 90 millivolts present. Now if suppose the cell is excited, okay, now second stage. Now we will take this as a second stage, okay, or when stimulation is given, or you can call it as an excitation. Okay, because of that excitation, what will happen? The membrane changes property to permeable for sodium ions. That means what will happen whenever the excitation is done? Okay, so the term I have used the excitation over here. Whenever the excitation is done, that time this particular membrane, which is earlier not allowing the sodium ions in, will allow the sodium ions to get in. Okay. So what will happen earlier? What will happen in the earlier case? The sodium ions cannot be able to enter, and they are more in number outside. Okay, and less number in inside. That's what it is negative. So what will happen? They will be present here. The sodium ions are present outside. They are more in number, and because of concentration gradient, they will try to move from outside to inside. But this particularly membrane doesn't allow them in earlier case. Okay, so as soon as the excitation is given, this will allow the sodium ions to go in. You can see all these arrows that is going in. Okay, all the sodium ions that it will be trying to rush in. Okay, and also the potassium is trying to come out. Okay, so the sodium carries the positive ions. So when that sodium will get in, what will happen to the inside the cell now? Can anybody tell? Now inside the cell, what will happen? Whether it is a positive or negative now. Now, is it positive or negative? See what I told, in the second stage of stimulation or excitation is given. Because of that, the permeability of this membrane will change. The sodium ions, which are more in number outside, they will try to get inside. Potassium will coming out. So what will happen to the inside of the cell, whether it is become positive or negative now? Yes, anybody can answer? Will it become positive or negative now? Abhimanyu?
Positive, sir.
Yes, very good. Okay, so it will become positive. So that means what will happen, because of this coming in the inside, the sodium ions, we can say that, so it becomes positive, and that positive potential is nothing but called as action potential. Okay, and that action potential is having the value of around plus 22 plus 35 millivolt. That is plus 22 plus 35 millivolt. Okay, this is the action potential. Okay, so this is second stage. First stage is the resting stage, second stage is the acting stage or action potential. Okay, so in the resting potential, negativity is there, action potential, positivity is there. Okay, this is the second stage. Okay, so you can just see here, what is written, that's the same thing what I explained, it is written over here. Okay, when a section of the cell membrane is excited by the flow of ionic current by some external applied energy, the membrane changes its characteristics and the sodium ions will come in and it will be going up to plus 20 millivolt as an action potential. Okay, action potential. So a cell that has been excited is called as the that action potential is developed, that is plus 20 millivolt. Okay, plus 20 millivolt. And one more thing is important over here. So this particular thing, this particularly uh, characteristics, it is termed as a depolarized cell. Okay, what is depolarized cell or depolarization? Depolarization means changes from resting to action potential, or we can say that changes from negativity inside to positivity. Okay, and that stage is called as the depolarized state. That is nothing but the, we can say, action potential. Okay, action potential, and this is nothing but the second stage. Okay, just a simple example I can give it for here, that initially what happens, initially we have the sodium ions outside are more. Okay, initially the sodium ions are waiting outside. Suppose the class started at the time what I have given, suppose 11 o'clock I have given you time to start the class. Okay, and then I will just block the entry for those students who are coming late. Okay, suppose your class strength is 29, out of 29 only 2 students have joined on the time, for example. Okay, and the class is going on, so I have allowed the permission for these 2 students to get in. Okay, and as the time goes on I block the entry for other students. Okay, so consider that these students are having the sodium, these students are nothing but the sodium ions. Now some latecomers will come and stand outside or wait for them to permit inside. Okay, but I didn't allow them. So as the time passes, 5 minutes, 10 minutes, more number of students are coming. Like suppose 27 students, they came late and they are waiting outside. Once I make them, allow them to get in, all they will rush to sit or come in the class. Okay, so that means what, the external sodium ions that are there try to come in and the class will be full of students. That means full charged. Okay, means initially it is negative, and when all students comes that becomes complete positive. All students are there. Okay, so that is what is nothing but the resting to action potential. You can make a similar similarity. You can find it inside in the examples. Okay, so that is a depolarization present. And what is in the what is the first stage? Again I will, first stage we are calling it as an resting potential. So that is having the negativity inside. First stage, I am telling about first stage. Negativity inside, and that stage is called as the polarized state. Okay, and that is the resting potential, and that value of the resting potential is minus 70 to minus 90 millivolt. Okay, so first stage is polarized state, second stage is depolarized state. Depolarized state. Okay, so this is the first stage, this is the second stage. Now again what happens, again this has to bring back to its original state. Now our target is to bring from action potential to resting potential. Okay, now this is what is the target is. So how this target is achieved, let us see. So this diagram here shown is the depolarized state, which is the positivity inside and negativity outside, and you can measure the positive potential, that is the depolarized state. Okay, now in order to bring from action potential to resting potential, there is a sodium pump. One concept is there, which is nothing but a sodium potassium pump. Now this is what is the second stage, we can say action potential or depolarized state is this. Okay, now we have to bring back it to its resting. To bring it to resting, what is done? There is a sodium potassium pump. So that pump is fixed over here in the membrane. That pump is like fixed over here. Here that pump is there, sodium potassium pump. So what it does, it will take 3 sodium out and 2 potassium in. Okay, so that means what? 3 positive charges are going outside and 1 and 2 positive charges are coming one side. Means what? There is a deficit of 1 positive ions. And like this, if the number goes on increasing, so what will happen? The deficiency of negativity is there, or we can say the deficiency of positivity inside than outside. That means what? Again it is becoming to the resting stage or polarized stage. Okay, so this is the third stage. Okay, that means what we have seen, the first stage is resting potential or called as the polarized state. Second stage is what? Action potential or depolarized state. And third one is what? The resting, again coming back to resting and polarized one. Okay, so thus this is the potential what it will be producing in case of the potentials. Okay, so this is what a plot is plotted here, you can see. So resting potential, you can see this is the resting potential having the value of minus 70 millivolt. Then as the excitation is given, it will be going toward the action potential. This is the second stage, action potential. So resting potential is nothing but the polarized state, we can say. Here I can write here that this is the polarized state. Then it is going towards the depolarization. And then again, because of that sodium potassium pump, it is again coming to polarized state, and that is what it is called as the repolarization. In this phenomenon, more number of potassium ions are going outside. That's what it will create this type of graph. Okay, so this is the waveform of action potential, it will be shown. Okay, waveform of the action potential, it will be shown. Okay, now this is what is the concept of how the cell producing the potential. So I'll summarize. The cell will produce the potential. Initially a resting stage is there, which is called as the polarized state where the more electronegativity is inside than outside. The cell membrane is semi-permeable. It won't allow sodium ions to get in for the first stage, and potassium ions are going outside. Because of that, more electronegativity inside. So that is first stage, which is the resting potential. The value of the resting potential is minus 70 millivolts for muscle cells and minus 90 millivolts for nerve cells. Then second stage, when excitation is provided, the cells will provide, the membrane will change its characteristics. It will become the permeable to sodium ions. So more number of sodium ions will rush in. It will create more positivity inside than outside. That stage is called as the action potential. Also, it is called as the depolarized state. The value of this is plus 20 millivolts for the muscle cells and plus 35 millivolts for the nerve cells. Then again, the third stage is to bring back to original polarized state or resting potential. For that purpose, sodium potassium pump will work. It will take 3 sodium outside and 2 potassium inside for net deficit of 1 positive charge. So in mass, if you study, it will create more negativity, more deficiency of positive charge, and again it will come to the resting potential, and that is called the repolarization or repolarization. And once repolarization is complete, it will become to the polarized state. It will become to the polarized state. Okay, and this is what is the graph what we have studied about resting and the action potential. Okay, now we'll come back again to our presentation part. I will share that PPT. I will share now. Okay, so this is what is the theory about this, what we have studied all the theory. Okay, how the potential is produced. Now this diagram shows how to measure the potential. Of course, you will require a potentiometer for measurement. Okay, so this you can see as a potentiometer. Then you will require some measuring sensor. So here, this is the cell, let us say. This is the inside of the cell and this is the outside of the cell. So you can see outside of the cell, it is shown the positive charge, and inside of the cell is shown as a negative charge. Okay. So when both the electrodes are outside, both these terminals of measuring thing are outside, then what the potentiometer is showing? Potentiometer is showing the zero value, because both the potential difference what you are going to get is from positive positive, so it will be showing you a zero value. Okay, it will be showing you a zero value. Now consider the next case. In the next case, what happens? This electrode is inserted inside and measured with respect to outside. Okay, and what you can see that this indicator will be toward the negative side. So what is this stage is? Can anybody tell? ही stage कुठली आहे? What this stage is? Venkatesh, Kushika, Atharva, anybody is there in the classroom? Sakshi Temburne?
Sir, second stage?
No, you just look carefully. Okay, the indication is showing the negative value.
हाँ, डिपोलराइजेशन होता है ना?
नहीं नहीं, ये देखो, ये इलेक्ट्रोड यहाँ पे इंसर्ट किया इनसाइड में. इनसाइड ऑफ द सेल क्या बता रहा है, पॉजिटिव है कि नेगेटिव है?
नेगेटिव वैल्यू.
हाँ, और आउटसाइड पॉजिटिव है, तो नेगेटिव इनसाइड कब रहता है, क्या स्टेज बोलते हैं उसको, विच स्टेज इट इज? more electronegativity inside than outside?
फर्स्ट स्टेज.
हाँ, फर्स्ट स्टेज है, ये रेस्टिंग वाला स्टेज है. जब भी रेस्टिंग पोटेंशियल बोलते हो ना, उसको तुम पोलराइज्ड बताते हो, पोलराइज्ड स्टेट. और वहां पे निगेटिव इनसाइड रहता है. देयर विल बी मोर नेगेटिविटी इनसाइड देन आउटसाइड. ओके. और membrane will be semi permeable. So membrane doesn't allow sodium to in. Okay, so that's what you can see here. Minus 90 millivolt bata raha hai na. You can see what diagram is showing is minus 90 millivolt. That means this is the polarized state. Okay, this is the polarized state. Initial starting. ये ऊपर वाला जो फर्स्ट डायग्राम बताया उसमें तो दोनों इलेक्ट्रोड आउटसाइड है, सो इट इज नॉट शोइंग एनीथिंग. ओके, जीरो बता रहा है. Okay, so same thing, the explanation is same thing what I have given. Now this is one more information you can have, additional one. So the diffusion potential across the membrane that opposes the net diffusion of particular ion is called as the Nernst potential. So you can have that Nernst potential equation like this. If you want to find out the EMF in millivolts, it will be depending upon the concentration of that specific ion, and that ratio of the concentration of the ions inside and outside it will be taken, and you can take plus minus 61 log of concentration inside divided by concentration outside. Sometimes it will be asked to calculate the Nernst potential. So that EMF, if you know exact the concentration of the sodium ions inside the cell, concentration of sodium ions outside the cell, you can calculate the EMF value by using this formula, that is the Nernst potential. Okay, Nernst potential that you can be able to find out. Now there are not only sodium ions are there, but sodium, potassium, chloride ions are there. So if you want to find out the total EMF produced by all the three ions, sodium, potassium and chloride. Okay, so that is equation is called as the Goldman-Hawkin equation. Okay, so that equation is shown over here. So EMF millivolt is given by minus 61 log of C stands for the concentration of sodium ions. These ions are plus inside I. Okay, into P stands for the permeability. Permeability of sodium plus ions plus concentration of potassium ions inside, permeability of potassium ions plus concentration of chloride ions outside. You mind this, chloride ions outside is taken, whereas sodium potassium is taken inside, divided by concentration of sodium plus ions outside, concentration of potassium ions outside into permeability plus concentration of chloride ions inside. So this is difference. Okay, so just you can keep this mind, or you can take down this equation, or you will get it in the book also. So this can be used for calculation of total contribution of sodium, potassium and chloride ions. Okay, so I'll okay, just now you take it down. So I'll give you sodium ion concentration outside is 142 and sodium ion concentration inside is 14. Now calculate the Nernst potential. All of you can calculate. Okay, You take it down, sodium concentration outside is 142, inside is 14. Use this equation. This equation you can use. So use this equation, concentration inside, concentration outside. So I have given you the concentration of sodium ion inside is 14 and outside concentration is 142. Now calculate how much is the contribution of sodium ions in the resting potential and tell me the value.
Sir, plus minus 141.322.
1 plus minus 1. Have you taken log?
Yes, sir.
You again recalculate it. Any other answer is coming? Anybody else? The other answer coming? Okay, this is what is the answer you can see. Or for I'll come to that point, but we will study this. This slide will give you the hint about that calculation. Okay. So the only movement of ions through the membrane is diffusion of potassium ions in the resting stage. Okay. So because of the high ratio of potassium ions outside to inside, that is 35:1. Okay. That means what? What is inside 140 by 4? So if you do 140 by 4, you will get 35:1 ratio. And the nearest potential, if you take minus plus 61 log of 35 by 1, so you will get the value of minus 94 millivolt. Okay, because of logarithm of 35 is 1.54 and this times minus 61 millivolt. Okay, so potassium ions 145 over 4 inside, if you take it is minus 1. Okay, since it is a positive, you are going to take it negative. Potassium ions are positive, that's what you will take minus 61 millivolt multiplied by 1.54, it becomes minus 94 millivolt. Okay, so the potassium ions were the only factor causing the resting potential. The resting potential inside the fiber will be minus 94 millivolt. Okay, so the contribution of the potassium ions as per that Nernst equation is minus 94 millivolt. Okay, this is what it is written here. You can see. Okay, so this is for the potassium we have calculated minus 94 millivolt. Similarly, for sodium ions you will get plus 61 millivolt. Okay, so 14 by 142 you can take and then try it out. 14 by 142, if you take it and then you try it, it will become as a plus 61 millivolt. So combination of both these by Goldman equation, you can get it minus 86 millivolt. Then the sodium potassium pump is there. This is like this. As I told that first stage is polarized state resting potential. Then stimulation is given. It will go to the action potential. Now again, to bring back to the polarized state, a sodium potassium pump will act there, and this sodium potassium pump, three sodium ions it will take inside. So see, from inside to outside, three sodium ions it will be taking it out, and two potassium ions it will be taking it in. So it will cause again the negativity, and the contribution of this is around minus 4 millivolt. That means you can see the contribution because of the potassium ions diffusion is minus 94 millivolt. The contribution due to sodium ions is plus 61 millivolt, and the concentration due to the sodium potassium pump is minus 4 millivolt. So in all, if you find out the membrane potential with this, all these factors operative, that it is coming as a minus 90 millivolt. This is what is the minus 90 millivolt it comes. Okay, so how this minus 90 millivolt come, it will give you the answer of this. Okay. Now this is what is the action potential we are measured, the measurement setup we can say. Okay, so you have here basically cell. So inside the cell, electronegativity and electropositivity, this factor it is continuously going on. So we are going to measure it. In the resting stage, it will be showing the negative value. Okay, so if there is the resting state, it is called as the resting state, you can see. So this resting state, we can call it as an polarized state. That is the first stage. Then it will go to the depolarization, or it will be going toward the action potential. So this is the overshoot. Again, the sodium potassium pump will act here to bring to resting position again. Okay, so here you can see a minus 90 millivolt to plus 35 millivolt is the range. Means resting potential is minus 90 millivolt and action potential is plus 35 millivolt. Okay, this is the action potential and this is the resting potential, and this is the measurement setup used for measurement of the signals. So this is what is the, again some more elaboration you can see. So action potential, it is be propagating like this slowly. So what is the characteristics of that action potential? This obeys the laws of all or nothing. That means what? When the action potential occurs, when some stimulation, excitation is given, but that excitation should be given with some threshold. Okay, some threshold it will be required. If the energy is below that threshold, it won't excite. It won't give the action potential at all. And once it crosses that threshold, it will be just obeys the law of all or nothing. That means it will produce the action potential. Okay. So that is what is the all or nothing law, that will be obeyed over here. So this is the thing what we have studied. Just you can read it out. This is the resting membrane potential before the action potential begins. The membrane is called as the polarized, and during this stage minus 90 millivolt negative membrane potential is present. So this is what we have explained. It is just a summary we can say. Okay, what is this resting membrane potential? First thing. Then the stage is called as the polarized state. Second information. And third information, it is producing the minus 90 millivolts and negative membrane potential is present. That is the fourth information about the resting stage. Okay. Now this is what, how actually the sodium ions will come in or not. So this is the first thing. You just tell me what is this first stage is called as. Here you can see the sodium ions, this is the gate. Suppose this is the cell membrane. Okay, this is the membrane. Okay, this is outside the membrane, inside the membrane. Now this gate is closed for sodium ions. Now you tell me what the stage is. It is the rest stage. Again you can see here activation stage, resting stage, minus 90 millivolt. And when it is activated, sodium ions will get inside. That is what is the, so this is inside and this is outside. Okay, inside cell, outside cell. So voltage gated sodium ions are there that can be able to measure the values. These are the potassium gated channels. Okay, so this is about the resting and the action potential. Okay, this is about the resting and the action potential. It is produced and its waveform. Okay, just a moment, if I can see some information, more information. Just a minute, I'll share the same thing, but I'll share it. Just we can have a look at this. So it will be again giving you the same thing but with details. Okay, resting and the action potential. So far, doubt, any doubt? You can ask, any doubts are there? Now this is what, once we know how the potential is produced, then we are going to study about the electrodes. How that electrodes it will be used for measurement of that signal, and that conversion of this ionic voltage into the electronic voltage and connected to the instrument for measurement of the signal. Okay, so that we need to study. Okay, so these all are the things that is just a revision kind of thing. Okay, so this topic is about the action potential and the resting potential. Okay, so all students have joined to this Google Classroom. I can find only 25 students. and your class strength is 29. Okay, so we'll stop here today.